Okay, so.
Can I explain the next one?
So when we have parallelogram, so the diagonals here, they're saying PT, which is that distance there, and TR is 2x plus 1, right? So what, in regards to the diagonals of a parallelogram, what is the relation that we can say about PT compared to TR? Okay, so we'll say Y equals 2x plus 1. The next thing they tell us is that QT is 4y, and T to S is 6x plus 10. So what can we say about those two distances? They're equal as well. So 4y equals 6x plus 10. So at this stage, we then need to rely, so that's all geometry. We now need to rely on our algebra skills to figure out what x and y are. And there's a lot of different approaches here. I think the best approach is probably the first one you learned last year, is that when you have a variable solve for, meaning that the coefficient is 1, is to just take that and come over here, and wherever you see y, replace it with the expression 2x plus 1. And then we're going to get 8x plus 4 equals 6x plus 10 when we distribute that. And then, so I'm going to move the 4 over, so give me a 6 here. I'll move the 6x over, it gives me 2x. So then x is 3. And now x is 3, and this is the reason I like substitution, because now it's the least amount of work, because now when I go back and solve for y, I can just plug it in there, and I should be able to get 7 back for y. Somebody in the last class did, and I think this is, it's not essential, but I think it's important to maybe talk about our options for algebra. You guys, when we do systems equations using elimination, you guys remember taking like whatever my x term or whatever my y term were in my constant, I set them up that way, and then in my other equation it might be something like this, and our goal was to add straight down, right? But that's the general format that we get every time that we do a system using elimination, right? That's kind of, and that's the way you're taught, because when you're done here, you're left with like a, let's put another variable, g of x or h of y is equal to some constant. And it's just really simple then to divide both sides by whatever g or h is and solve for x or y, right? You don't necessarily have to do that though, okay? As long as your objects are all aligned the same way. So if I look at that, are my y's on top of my y's? Are my x's on top of my x's? And my constants on my constants, right? So can I multiply the top one by -4? So it's going to be negative 4y. That's going to turn into negative 8x. And then this will turn into negative 4, right? Now if I add straight down, you get 0 equals, straight down will give me negative 2x. Straight down gives me plus 6, right? Can you solve that equation then? And that's a two-step equation, right? Add 2x to both sides and divide by 2. Where if I would have lined everything up, all my x's on the left-hand side, all my y's on the left-hand side, it's a direct 2x equals 6 statement. But it shouldn't matter. Still get x to be 3. Does that make sense, everybody? I think, if I'm doing something on my own and I'm not teaching this or trying to provide you that instruction, and I'm just trying to solve for x on my own for whatever purpose I'm needing it, when I have this equation, what was it, 2x plus 1 and 4y equals 6x plus 10, that's what I do. Because I think in order to rewrite those two equations so that they're in ax plus by equals c form, that's more work than solving that equation that I got at the end of 0 equals negative 2x plus 6. Does that make sense? So kind of knowing that payoff, kind of move accordingly through the problems, knowing my options and the time that's going to take in regards to those two options or three options or whatever. Okay? And that's the thing, again, as we continue to go through the course, guys, every once in a while systems pop up. So I think there might have been one towards the end that was like that as well, right? 17. What about, I just want to real quick look at this one right here. What is the relationship between these two angles? Supplementary. So I'm going to add those together, sum equal 180, right? Okay. Is that question right there exactly the same as that question right there? Yes, but no picture, right? Okay. But procedurally, they're the same, right? Okay. So make sure that we can kind of pick up on that. And if you need to draw a picture, but you're going to approach this question the same way as that question 12 or 13, whichever one that was. I want to talk about 18. Okay. And the example that I give you guys to help you kind of understand the algebra, remember the algebra here is, if I told, and I can give every class this, so if I told you that my brother is 6 years older than me, which person do you know more facts about? My brother. Okay? So you know very little about me, right? So what you would do is you would let me be the variable. So Mr. Fay's age is going to be X. Mr. Fay's brother's age is going to be X plus 6. Okay? So when trying to come up with expressions for your components to these types of problems, and we call it defining our variables. When you have to do that, the safest thing is to allow the thing you know the least amount of information about be your most simplistic variable, okay? Usually X. You can do it the other way. You can let my brother be X, but then so I tell you my brother is 6 years older than me. You let him be X. What do you have to let me be then? X minus 6, right? But in my description, I said he is 6 years older than me, or 6 years more than me. More means plus, right? But when you wrote your expressions, there's not a plus in there, right? If I want to use the words that are in these statements, like more or twice, the way that I think about them, more means plus, right? If I want to use plus in my definition of my variables, then I have to choose the thing that I know the least amount of information about to be my variable. Okay? Otherwise, I got to think backwards. Okay? When you let my brother be X and then I'm X minus 6, well, that's thinking a little bit backwards, right? Okay? But once you can kind of convince yourself in all of the mathematics that we do, whether it's this class, Algebra 2, college algebra, trig, calculus, whatever, when you're seeing problems, when you have to make these decisions, you have to define variables. Think about the thing that you know the least amount about, okay? My college algebra students had to take a final today. So let me see if I can pull up one of these real quick, just to give you an example that this comes up again at some point. I'm not 100% sure what the question was.
That one right there.
All right, so it says, on a Saturday, 3 times as many children enter the park as adults. Okay? 3 times as many children entered the park as adults. Do you know anything about adults? How many entered? No, they tell you most about children, right? So I let adults be the simplest variable, okay? And then 3 times that would be equal to the children. Does that make sense to everybody? Okay? So you see this kind of procedure occurring in other aspects of math, okay? And once we can convince ourselves of that, I think it's gonna make your life a lot easier. Because I think some people see story problems like this and they shut down because they don't know how to define those variables. This is what we do. We say let AB equal X. Okay, because AB is the thing we know the least amount about here, right? Because AD is, so when they say is, that's equal, right? So they're telling me everything I need to know about AD. They don't say a single thing about AB. Okay? So if AB is X, AD would be what? Okay, you could say Y. Okay, but what's that do? Now I've got two different variables, and that's problematic for setting up equations and solving things, right? Okay, if I let it be Y, because it is different, right? But it's different through the use of AB. We can figure it out through the use of AB and not have to introduce a new variable. So what should I let it be? 2x plus 10. Is that what you're going to say? 2x plus 10. That's 10 more. 10 more, so plus 10 of twice x. Well, twice x. X was AB, right? So twice AB. And now do you see how that allows me to kind of maybe work through this problem a little bit better than letting that be y? Okay. So now when it says the perimeter is what? Around. So I'm going to choose a vertex and let it be A. Does not matter what vertex it is. It could be that one, that one, that one, that one, doesn't matter. But now when I go to B, where does B have to be? Here or there, right? It's got to be one of the consecutive ones. So maybe I put it there. And now that I've defined that I'm going to go that direction, so around this shape I'm going clockwise, then I need to go from B to C, right? And C to D. Because now if I were to just kind of willy-nilly A, B, C, D like that, and I asked you to look at AB, well AB is that distance right there, right? Yep. Is that dotted distance part of my perimeter? No. Okay, so that's the purpose of why we've got to be able to go from A and then work to consecutive vertices. So now AB is X. What's DC then? X. AD is 2x plus 10. What's BC? 2x plus 10. What can I do now if I'm going to work with perimeter? Add them up. So we get 6x plus what? 20? Should equal 86. Okay. So 6x equals 66. X is 11. And if x is 11, can I plug that back in, get 22 plus 10? Be 32? Okay. What if I just wanted to look at these two? What if I didn't even have those two, and I didn't want to use that property that opposite sides are congruent? Okay, I guess I do still have to use it, I have to have an understanding of it, but I don't use it in my formula. What could I set, what if I just add those two things together? What would I set those equal to? Half of what? Okay, so I would say 2x plus 10 plus x is, because that's half my shape, right? That'd be half my perimeter. Okay, so you can do that. That just allows you to maybe work with smaller coefficients, but either way should be fine. Is it okay? All right. Are there any others on there that you guys want to talk about? That... Maybe in another day.